Missing, so I'll have to talk reasonably loudly, which I hope I can do above the snores. I'm also going to take my care because when I actually drove in this morning, I was listening to something on Radio 4 which said that each year flip-flops cause £20 million worth of damage to individuals. So if I suddenly trip over and break my neck, then that's contributing towards the problem. So thank you very much for coming along. It's really very nice to see so many people. I hope you haven't broken off from your holidays just so that you could come and listen. If you have, I'm sorry about that. So you know the basis for these seminars. The first one that was delivered by Paul and Greg was on bioenergy. And what we're trying to do is pick up on topical issues. And I suggested that I talked about food security. Food security is something that the university has identified as a priority, and it's asked me if I would be involved in trying to drive this forward. Food security, probably 2 years ago, none of us would even have heard of. So what I want to do is talk a little bit about food security, global food security, and also talk a little bit about GM, because these things do go hand in hand, and this particular school has got a long tradition for working on GM. So that's the working title. If, as I'm going along, people want to ask anything, please do. So these are some points that we need to take into account. And some of you need to take this into account more than me, because these are things that are going to unravel over the next 30 to 40 years. So there'll be an increase in demand for food by about 50% over the next 20 years. If you think about that, that's an enormous increase. And in fact, it has been suggested that we will need to grow as much food over the next 20 to 30 years as we've grown in the total history of mankind so far. So we're talking about massive increases potentially in the amount of food that we need to grow. Part of that's being driven by the fact that there's an increase in the global population, which is predicted to approach 9 billion, maybe more than that. And it's also driven by the fact that many of us have expectations. When we go home at the end of today, or even at lunchtime, the expectation is that we won't be eating just a few bits and pieces, that there'll be quite a lavish meal for us, and it'll contain quite a lot of dairy products. And as people become more middle class, they have an expectation for these sorts of foodstuffs, particularly more meat and fish, and all of this is very energy intensive. So just something about global food security. What does it mean? Well, if you are food secure, you don't live in hunger or fear of starvation. And I suspect that none of us are food insecure. Is that fair? We all know we're going to have lunch soon, and some of us would like it to be sooner rather than later. But for many people, this isn't actually the situation. These are just some numbers that you might like to take into account. It's proposed that at this moment, whilst we're sitting here, hopefully enjoying ourselves, 1 billion people are hungry. And there are 2 billion people who actually don't know where their next meal is coming from. So that's a lot of people who either are hungry, have no food, or they're not sure where their next meal is coming from. And they're people who we would describe as food insecure. 3 billion. There are 1 billion people who are classified as medically obese. And there are 2 billion adults who are described as overweight. Now, just if you have a look at those two sides, we're saying 3 billion people haven't got enough food. 3 billion people potentially have more than they need. That's quite alarming. Now, it would be extremely simplistic to say, well, we can solve the problem just by moving the food to the people who eat too much. So our lunch we shouldn't have, we should actually give it to somebody else. Is that something that everybody's happy with? Yes, I can see. So cancel the lunch, please. So the point is that it's very simplistic to suggest that we can move food around, but it is quite a salutary statistic about those two parts of the story. So we have a bit of a challenge here, and this is what the challenge is. We need to increase food production. I think most people would agree. But we're going to actually have to use the same amount of land. Unless we discover another planet tomorrow that we can exploit, we're going to have to use the land we've got. But there are some caveats. One of the reasons why we manage to grow so much food is we use a lot of fertilizers. We're not going to be able to do that in the future. We're going to have to use less fertilizers, probably 50% or more. We're going to have to use much less water. It depends where you live, but in certain countries, I was in China a couple of weeks ago, water is a real problem in parts of China. It is obviously elsewhere in other parts of the world. So we're going to have to use less water, and we're going to have to use less energy. And we're going to have to do it sustainably. At the moment, we don't necessarily worry about sustainability. We know that there will be something there in the supermarket next week, even if we throw the last product away. We can't do that anymore. We're going to have to somehow make use of our resources and do things in a sustainable way. And there's something that I haven't actually put in there. That's in the absence of things like climate change. So we would need to do those four things irrespective of whether climate change is going to be something which is going to add to our woes. So that is the challenge, and this is what makes what's called the perfect storm that some of you will have heard about, which is really how do we bring all those things together. So, is there a role for genetic manipulation of crops? And that's really what I want to talk about. Is it something that we can add as a tool to our armoury? It isn't the solution, but is it something that we can actually exploit? So I want to give you a few examples, and I'm going to draw on the things that we've actually done here, because I think we can be very proud as a community about, over the last 15 or so years, what we've done in the GM area. A little bit of history. This whole aspect of science is really very new. Now, you can track it back to 1953. Now, there's nobody in this room who was born in 1953, so none of us will remember the structure of DNA, and nobody was born before that, so we don't need to worry. This is before our time. Some of you will have been born at a time of the Green Revolution. Green Revolution wasn't anything to do with GM, it was all to do with plant breeding and developing new traits that were advantageous, particularly crops that were much shorter, dwarf crops that would actually give rise to potentially greater yields. The start of GM, in a way, you could track back to 1972, when people realised that DNA you could do things with. It was the blueprint for the form that we have. So all of us actually contain DNA in all our cells, or nearly all our cells, and strangely enough, our DNA is very similar. You might not wish to recognise that your DNA is very similar to mine, but sadly I have to tell you it is. Very, very similar, just minor changes. In 1972, it was identified that you could move bits of DNA around, and you could actually put bits of DNA back together again. And a year later, it was identified that you could actually insert foreign DNA. So you could take DNA from one organism and put it into another. These were bacterial changes. But that was very powerful because it allowed you to change the way, potentially, an organism developed. This led to people being worried. So people thought, well, this is tremendously powerful. If you can change the DNA, we can potentially make all sorts of organisms which previously didn't exist. We can play God. This is so concerning, so ethically challenging, that we really need to think perhaps we should have some rules about this. And in fact, it was suggested that the whole work should stop because this is potentially so